We also, in the IUPAC names, we have some trivial names that we use, and they're shown here. You can see that we have 4 different classes. We have classes with 3 carbons, 4, and 5. Okay. And with the 3 carbon group, we see we have a propyl. Now the squiggly sign right here is showing us that this substituent is coming off the parent chain. So when we have a long parent chain, let's draw an example here. So we have a long parent chain. When we have a 3 carbon group coming off, there's the propyl. But you can have 3 carbons that look a little bit different. You could have it come off like this. And that is called an isopropyl. Or the IUPAC name says it's the 1-methyl ethyl. So that top name shown there is what I've taught you. And then in the parentheses is the common name. And this is the way I like to name my substituents when I'm naming molecules. So I'd call that, if I saw that substituent, I would call it an isopropyl. I would not call it a 1-methyl ethyl. But this is all your personal preference. If you use either one, you would get 100% on the test. Okay. Now with the 4 carbon group, we see the butyl, and in parentheses we see that it has an N-butyl. The N just stands for normal, a normal butyl, and a normal butyl is just a linear chain. But now we have a isobutyl. So if I drew it on this parent chain, an isobutyl would look something like this. Do you see how that substituent has 4 carbons? 1, 2, 3, 4. There's the isobutyl. But if it comes off looking like this, it's a sect butyl. And if it comes off like this, it's a tert butyl. I typically draw tert butyls like this, just for quick and easy. Just looks like a cross. That's a tert butyl. There's 4 carbons right there. And then with the 5 carbon group, we have an isopentyl and a neopentyl. Now, can you see, looking at all the isos, it just, it looks like a Y or a V, however you want to look at it at the very end. There's the V, there's the V, and there's a V. Okay. So iso means that V-looking shape. So if we go back, we can look at all the molecules that we've named. And I want to show you how the names look like with the common names. So let's go here and look at a previous molecule here. So let's look at this guy. Okay. What's another way we could, let's rename this molecule using the common names for the substituents. Okay. And the name that it would now be would be a 4. What's that substituent called? That's called a tert butyl. So we'll go tert butyl dash 5 dash. Wait, this one's a diethyl. diethyl nonane. Oh, I messed up. That comma 5 dash. There we go. So it doesn't matter if you on the exam wrote this as the name or this one, you would get 100% on either one. My preference is the second one because I like to use the common names for the substituents. Now look at this here. Why did we put the tert-butyl first? Well, you have to remember, if we go back to these rules right here, it says the tert right here is ignored when you're looking at the abbreviations, or not the alpha, when you're alphabetizing things. So we see here we are looking at the B compared to the E. And B comes before E. That's why we put the tert-butyl first. Let's see. Let's find another example that we did previously. Let's scroll up here. So now, if we look at this molecule right here, we see all the substituents are simple, or 3 of them are simple, and 1 that's squared in the purple is very complex. There's no common name for that. So with this molecule, you're going to be forced to have to label out the substituent. Okay, let's see here. Not that one. Let's look at this one. It's the 3,1-methyl-ethyl-2-nitrohexane. But we can rename this with the common names. And I'm trying to find it in my notes. There it is. If you would have written this molecule name as this, you would have got 100% points also. What functional group is that? So let's clean this up a little bit. What is that functional group right here called? How many carbons does it have? You see that it has 3 carbons. So that has to be an isopropyl. So isopropyl. And we see that the isopropyl is on carbon 3 dash 2 dash nitrohexane. Now let's take a look here. We have to be careful. When we alphabetize these, we know we're going to look at the N, but what do we compare it to? The P or the I? Well, when we go back here to our rules, it says that the iso and the cyclo, you include those when you alphabetize things. So we are comparing the N to the I, and I comes before N. And so both of these would be 100% correct. And you get to choose what method you'd like to do, but as you work through the homework problems, you will find in the homework problems the only answers you will see typically are going to be these. Well, I take that back. You might see some of the answers in, like the purple name there too. But the main point is, do what works for you, and I will make sure you get the points that you deserve. It doesn't matter what type of, how you name it. As long as it's correct, obviously, right? So those are some trivial names that you should have understood, because you will see these on standardized exams over and over and over again. These common names, because just like that name implies, the common name If they're so common, then that means every organic chemist should know what they are, right? So I would personally put a little effort into knowing these substituents' names. Now we have rings. And we have all types of ring sizes. And when you look at the ring sizes, you can see that this right here, how many carbons does it have? It has 3 carbons. Hence, you see in the parent name right there, you see the prop. Come on, pen. It's not working on for me here. So we see the prop right there. That's telling us we have 3 carbons. And then the ane tells us that we don't have any double or triple bonds. And then we have a prefix right here, the cyclo, which tells us that the 3 carbons in propane are in a ring. So we have a cyclopropane, cyclobutane, all the way to cyclooctane. Now, rings can also be substituents. And when they're substituents, you do the same thing that we've done before. So you see with cyclopropane, we take the ANE and replace it with the YL. So if the cyclopropane ring is a substituent, so let's say something like this, we can see that is the substituent, and so that would hence be called cyclopropyl. Nope, I don't need virus protection right now. Now, naming an alkane that has a ring, you're going to come up against an issue. When do you use the ring as the parent name? Let's see here. Okay. So when do you use this ring as the parent name? So what is this? This is a cyclopentane. How do you know if this is the parent or a substituent? And the trick is you look to find the longest carbon chain. Okay, so ignore the ring for a moment and you just look for the linear carbons and you find and trace the longest chain. If the longest chain has more carbons than the ring, then the ring is a substituent. When you look here, we find the longest carbon chain, and I will number that there. So we see 1, 2, 3, 4, 5, 6. So the longest carbon chain right there is 6, but the ring has 8. So now we see in this second example here that the ring is the parent name, and you see the parent name right there, cyclooctane. But in this first example here on the left, we see that the parent name is what we see here, that it is a octane. Okay? And this 3-methyl right here is the substituent there. And then the cyclopentyl is the substituent on carbon 2. Now, if the molecule's root is a cycloalkane, and there's substituents on the ring itself, then we need to follow the same rules that we've done in the past. You're going to label carbon 1 with the carbon with the most substituents attached to it. and then you go counterclockwise or clockwise to number the next substituent with the lowest locator number. So in this particular example, we see that the carbon that's going to be called number 1 is going to have 2 substituents on it, and that's what we see. And we numbered counterclockwise because if we go counterclockwise, we will hit the second substituent with a number 3. Instead of if we went clockwise, we would have reached it in what? 1, 2, 3, 4. We would have reached the second substituent in 4, and that's just a higher number. And then after we've numbered the cyclohexane ring, we will then look at the substituents and organize them by alphabetical order. And we see B comes before C, which comes before M. Pretty straightforward. Now let's shift our group or move on to learning how to name ethers. Remember that ethers have this general formula where it's an oxygen in the center and you have 2 alkyl groups on either side. And in order to name an ether, you need to look at both R groups. Sometimes they are the same and sometimes they are not. So let's look at naming an ether with the IUPAC name, okay? So the general form is an alkoxyalkane. So what that means is that the substituent is is obtained by removing the suffix YL from the name and replacing it with oxy. So for example, let's look at this molecule right here, the dimethyl ether. And that is in parentheses, so that's just a common name. And the name on top is the IUPAC name. So what we do is we look at both of the R groups, the methyl and methyl, and we determine which one is the longest. And we can see that both are the same. So we just leave it be and we say, okay, we'll just call this one the longest. And what would that parent name be if we were just looking just at this? How many carbons are there? Just 1. So the parent name would be methane. And then you look at the other R group and you name it. What would you name that? That would be a methyl, right? So let's write that down. So we would call that a methyl. But in this second bullet point here, it says you have to get rid of the YL and replace it with oxy. So that would be a methoxy. And then you put the methoxy first in the name. So it's kind of like a substituent to the parent chain. So we have methoxymethane. And that oxy right there is telling you that you have an ether. Now we will skip this one because it's the exact same process before, but let's look at this one to the right. So let's simplify this down. We have an R group, an O, and an R prime. We can see that there are 2 different R groups. So we look at the first one, so the one on the left. We see that it has 6 carbons. And we look at the one on the right and we see there's only 3 carbons. So because there's more carbons for the one on the left, that is going to be our parent name. So we see the cyclohexane. There's our parent name. Now what would we call this if it was just a substituent? We would have called it a propyl. but we have to replace the YL with an oxy. So that's where you see the propoxy right there. Propoxy cyclohexane. It's really, really straightforward. And here are some other examples on how of other ethers that you can see. Now, you see this one right here in the middle. Typically, I've been showing you to draw them like this, right? Because we look at the general structure like that. But we could look at the general structure like this. Okay? So don't get confused by the orientation of the molecule. And we can see here that we have two different R groups. There's one, there's one. Which one's the largest one? Clearly the one on the bottom. And there's only 3 carbons, so that makes us have that parent name. And then we see that's a methyl group, so we call it a methoxy. But now we have to stick numbers at the front there to tell us where that methoxy group is attached, because the methoxy is actually that whole piece. So where's that methoxy attached to? It's attached to carbon 2. If we go to this example on the right here, we see the longest parent chain is the propane. There it is, longest parent chain. And then here's the methoxy group. And we see that it's attached to carbon 1. Now if we get a little bit more fancy here, we have a diether. So we have an R group here and an R group here for this oxygen. Right there. And then we have another ether here. So there's an R group and it shares the same R group. And we can see that everything's symmetrical here. And so we see that this R group and that R group's the same. There's only 2 carbons, but this R group there that they both share has 6. So that's going to take the parent name, and we see that it's a cyclohexane. We have to number the cyclohexane. And when you look at the name, how do we know this is a ether? Because of that oxy right there. And where are those ethers or ethoxys located? They're located on carbons 1 and 4. And why do we put the di? Because we have 2 of them. Okay, so you can look through these examples and see how they're named and work through those. So many organic compounds, they have these special names, or what we call common names or trivial names, because we've had molecules, and we've had molecules way before the 1900s when the IUPAC organization was organized. And habits die hard, or names have a hard time going away. Like, could you imagine the world saying, we're no longer going to call H2O water. Everyone now has to call it dihydrogen oxide. Wouldn't go over too well, would it? So common names stay around for a long time, and probably forever. We just need to understand what they are so we don't look like we're a fool when we're talking to other chemists. And so you'll see these names all throughout lab and lecture and whatnot, and you'll just learn them as you continue through the course. I don't want you spending large amounts of time just memorizing names of molecules. You have better things to be doing. But as you continue on in your science career, these molecules will always pop up, and you'll just learn them and you'll understand what they mean. Okay? Now we have to be able to describe carbons. not all carbons, well, when you look at a alkane, you're going to have 4 different possible types of carbons. You're going to have a primary, secondary, tertiary, or a quaternary carbon. And being able to identify what type of carbon you have is essential for your success in this course. Because certain reactivities and certain reactions will occur or not occur depending on the classification of the carbon. So you have to be able to see this, that you see how this arrow is pointing to this carbon right here? It's a secondary carbon, and you need to know that it is a secondary carbon. So how do you do it? So let's go and write it out. So let's see, I want black. Okay, so let's draw some arrows here. What is the classification for that carbon? How do you know? Well, I'm talking about that carbon, so all you have to do is ask how many other carbons are directly attached to that green one. And you can see that on this carbon right here, on that carbon, what do we actually have? Let's expand it out. We have a methyl group, right? So this carbon underlined in green is attached to 3 hydrogens and 1 other carbon. So this carbon right here is a primary carbon. Okay? Now, what if I want to know what is the classification for that carbon? Well, you just ask how many carbons are directly attached to the one I'm pointing to by the arrow. I see that I have 1, 2, 3. There's 3 carbons directly attached to it, so that would make it a tertiary carbon. What about that carbon? Well, we see that carbon that I'm pointing to with the red arrow is directly attached to this one and that one. So that would make it a secondary carbon. And let's draw our arrow and look at this one. So we're looking at that carbon right there. How many carbons are directly attached to it? 1, 2, 3, 4. So that makes that a quaternary carbon. And so that is something you would be expected to do on the exam. I will have a molecule for you, and I will have arrows pointing to certain carbons, and you need to tell me what is what. So if we did this whole molecule, we would say that one's a primary, that one's a primary, 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 that one's a secondary. And so we have labeled now every single carbon, or we classified each one. Okay? Here's some trivial names for some common alkyl halides. You don't need to spend time to memorize these. You will just, as you continue on in your career, you'll learn these and just know what they are. Everyone's heard of chloroform. Well, that's what it looks like. Its IUPAC name is called trichloromethane, but I'm not going to say, hey, get some trichloromethane from the stockroom. I'm going to say, get some chloroform, and you'll know what I mean. Methylene chloride is another common name. This solvent we use a lot. Let's see, what's some other ones that we use a lot? Not necessarily in our lab, but in a research organic lab, you use carbon tetrachloride a lot to, this is a solvent that you use to do your reactions in. And here's some trivial names for some other ethers. I don't need you to memorize these. These are just here for your information. You'll learn these as you progress through the course. Don't focus too much of your time on them. Okay, that is the end of the chapter A. And every week we will just continue to look at new chapters, or the nomenclature chapters. So this nomenclature chapter is just scratching the surface. There's so many other functional groups that we need to learn how to name.